Here is some practice problem from section 7.3 about trig substitution questions. Now, these kind of questions can have any of these three cases. Either it's in a square minus x squared square root format, or a square plus x squared square root format, or x square minus a square square root format. So we notice that this one is this last case. In these cases, with a here is a square is 4, so a is 2. Okay, that means our substitution which we need to decide, the first step is to decide the substitution. It's a secant theta, so that would be 2 secant theta. Okay, we differentiate. Whenever you need to substitute, we need to differentiate. So that will be 2 derivative of secant is secant theta, tangent theta, d theta. We are writing in the differential format. Okay, so let's see if this works here. Square root. In place of x, we are writing 2 secant theta, so it will be 4 secant square theta minus 4 divided by 2 secant theta times dx can be replaced by this whole thing, 2 secant theta tangent theta d theta. We see that secant theta can be cancelled, reduced to 1. We have 4 factored out, and this is secant square theta minus 1 divided by, actually this 2 is also being cancelled, so we don't really need to write anything in the denominator, times tangent theta d theta is equal to integral square root of 4 is 2, and this part secant square theta can be replaced by tangent square theta, and there is a tangent theta out, d theta. That becomes 2 outside. Square root of tangent square theta is tangent theta times there is already tangent theta, d theta. This becomes tangent square theta, d theta. Now we don't really have a direct method to find the integral of tangent square theta. So we can replace tangent square theta by secant square theta minus 1. Now if you remember, we have a formula for integral of secant square theta, that is tangent theta plus c. We're going to use that here to integral of secant square theta is tangent theta minus integral of 1 is just theta plus c. So we are done with integration, but pay attention. Our original question was in terms of x. So our answer has to be in terms of x. Now here is a small trick which we use. We look at our substitution one more time here on the side. Is x is equal to 2 secant theta. Then x by 2 is secant theta. Secant theta is reciprocal of cosine, so cosine theta is 2 by x. If we want to think in terms of right angle triangle, cosine theta is usually adjacent over hypotenuse. So this side is 2 and this side is hypotenuse is x. Using Pythagorean theorem, this side would be x square minus 4. Do you guys see that? If this is theta and cosine theta is 2 by x, so this way we can form the triangle. And now in our question, we need tangent theta. So tangent theta from this would be opposite by adjacent. So square root of x square minus 4 by 2. Also, we have theta to think about. Theta can straight come from here. This one actually. theta is equal to secant inverse of x by 2. So let's write this down. This is 2. In place of tangent, we can write square root of x square minus 4 by 2 because of this. Minus in place of theta, we can write secant inverse of x by 2 plus c. That comes up when I multiply 2 inside, it's only x square minus 4 minus 2 secant inverse x by 2 plus c. Let's write it correctly. This is your final answer. Your final answer should be in terms of x. Don't leave the question here that you can only get some points off. So your final answer should be in terms of x. And I do want to point out, if you notice in the question there is x square minus 4 square root, and in the answer also that same expression is coming up somehow. So that's kind of your clue that you see that.